Hello guys, let's talk about series. By definition, series are just terms of a number pattern when you are adding them together. If you write 4 plus 7 plus 10, now that's a series. So that's what we'll be talking about. We shall introduce this series notation and we shall introduce the sigma notation. Now we have an example here. We have a linear pattern 4, 7, 10, and they say find the general term of the pattern above. We have done this, and this is the calculation, and this is now the general term. Now when you are dealing with series, we'll be dealing with the pattern itself, or you'll be dealing with this formula. So that's why you were learning how to use this formula. Let's say you are given a number pattern and they ask you to find the sum of the first 4 terms of the pattern above. What you do is you use what we call the series notation. You write Sn. Okay, this is the series notation. It means you are going to add how many terms? They said the first 4 terms. So you write S4, meaning you are adding 4 terms, is equals to, let's look at this pattern, 1, 2, 3, 4. So we'll be adding this 4 plus 7 plus 10 plus 13. So S4 is equals to, if you add this, that's 34. Example 2. Find the sum of the second, third, and fourth terms. We are still using the same series. We write sum or series, sum of how many terms? From the second to the fourth, that's 3 things. So you write 3, 1, 2, and 3. Find the sum of the second, third, and fourth. So second, third, and fourth. Second, third, and fourth. 7 plus 10 plus 13 is equal to S3 is equals to 34. Example 3. Find the sum of the first 3 terms. 4, 7, and 10. So S is 3 terms, so it's just S3 because we are doing 1, 2, and 3. S3 for sum of 3 terms is equals to 4 plus 7 plus 10. So S3 is equals to 4 plus 7 plus 10, that's 21. Now I want you to look at this versus this. This is the sum of 3 terms, this is the sum of 3 terms. This is 21, this is 34. That's the problem with the sum of series. Sum of series, let's say sum of 3 series or sum of 3. You see, we are all getting it from the same pattern, but S3 is different in each time. So this one is less specific. So this one, the sum of series, is less specific. We want to introduce this notation called the sigma notation. It's more specific. Don't worry, it will be doing one and the same thing. It's just the capital letter S in Greek, just the same as the sum, the series notation which we're using. It's going to work the same, but it will be a bit more specific. The Greek letter sigma, and you are going to write Tn next to it, then is equals to whatever you want to write. Down here is going, let's just put index is equals to 1. I'll explain this, then we put n on top. Now, this is basically the sigma notation. This, we call it the lower value, and this, the n, we call it the upper value. Let's say this is a 1 and this is a 10. For you to get from 1 to 10, you have to add plus one integer at a time. That's a must. So 1 plus 1 plus 1 plus 1 plus 1 until you get to 10. Okay, if this is 1 and this is 3, it's 1 plus 1 plus 1 until you get to 3. Why am I saying this? This number is not always 1. This is where this is more specific than this. You state your lower number. If your lower number is 3, you put a 3 here. And if your upper number is 6, you put your 6 here. Sometimes they don't even give you a 1 here. They can give you a 0 or a -1 or a -2. We shall see. So when we started in the introduction, we had this pattern, and we said you can calculate its general formula to this. Now, in sigma notation, we'll be using this. Example 1, we have this pattern again. Use the sigma notation to find the sum of the first 4 terms. Now, you write your sigma sign. The first 4 terms, it means term 1, term 2, term 3, and term 4. Remember, next to sigma, you always write Tn. Your lower n is equals to 1 because you are starting on the first term where n equals to 1. And you are going to end at 4 where n is equals to 4. So basically this is what you are supposed to write. But there is a specific formula for getting this sequence. Remember when we started, you said Tn is 3n plus 1. So this will be, you have to be specific now. In place of Tn, you write 3n plus 1. So this is the sigma notation. Now we need to calculate and get the answer. Let us do the calculation. This is going to be, when n equals to 1, this will become 3 times 1 plus 1. Okay, we have to add, what's the second term? When n equals to 2, 3 times 2 plus 1. Remember, we are substituting into n. Plus when n equals to 3, 3 times 3 plus 1. And lastly, when n is equals to 4. Remember, you start from 1 and you add 1 at a time up to 4. So this will be 3 times 4 plus 1. So let us simplify. 3 plus 1, that's a 4, plus, this is a 6 plus 1, 7, plus 9 plus 1, this is 10, plus 12 plus 1, 13. So if you add this together, you get a 34. So your final answer, you write it this way. The sum of 3n plus 1 from the first term to the fourth term is equals to 34. So if we were using the sum of series, we would have written S4 is equals to 34. Find the sum of the terms from the second to the fourth term. Let's say they say use the sigma notation. So you write your sigma notation and you write Tn, and we are supposed to find from the second to the fourth term. So n is equals to 2 and the last one is equal to 4. Okay, so this is equal to the sum of n equals to 2 up to 4 and 3n plus 1 is the formula which governs this number pattern. So when they are saying use sigma notation, you have to go through all the steps to find the general term, then you take the general term and put it on the sigma notation. So this will simplify to 3 times you are starting at n equals to 2 plus 1 plus 3 times n equals to 3 plus 1 plus 3 times n equals to 4 plus 1. We are stopping at n equals to 4. 6 plus 1, that's 7. 9 plus 1, that's 10. And this is 13. So if we add this together, 10 plus 20, 30. So your final answer, you write your sigma notation. You are starting at n equals to 2 and you are ending at 4. And it's 3n plus 1 is equals to 30. If you were using the sum of series, how many terms are you using here? From 2 to 4, there is 2, there is 3, there is 4. You would have written S3. So let's do an example with geometric. Find, using sigma notation, the sum of the third, fourth, and fifth terms. Now, the moment they say find the sum or they say sigma notation, just know that you need to find Tn first. So it's also a way of saying find the general term, because the general term will always be next to the sigma notation. So let's quickly do that. If you divide here, you get a third. If you divide here, you get a third. So R is equals to 1/3. A is equals to 2, the first term. So Tn is equals to A times R to the power n minus 1. Tn is equals to A is 2 times R is a third to the power n minus 1. So we have our Tn now. Now, we want to find the sum. You write the sigma notation. We are starting from the third term. N is equals to 3. And we are ending on n equals to 5, the fifth term. And you write Tn. So this will be sum of n is equals to 3 up to 5. And you substitute Tn and you put 2 times a third to the power n minus 1. So let's calculate. The first one is going to be 2 times a third to the power n is equals to 3. 3 minus 1. Plus the second one, 2 times a third, n is now equal to 4. Remember, 3, then 4. Plus 2 times a third, the last one, n equals to 5. Two times this squared is a ninth. 2 times so the final answer Here is our last example. Find the sum of the 5th to the 8th term in sigma notation for the quadratic number pattern. Okay, so you write your sigma sign. The lower term is the 5th, n is equals to 5, and the upper term is 8, is the 8th term. You write Tn. This, more specifically, n is equals to 5 up to 8 to n squared minus 2n plus 6. So let us solve that. This will be equal to, right, this 2 times n equals to 5. That's where we are starting. 5 squared minus 2 times 5 plus 6. Then you add the last term, it's 8. 2 times 8 squared minus 2 times 8 plus 6. That's the last one. So this will be, put this in your calculators. This will be 46 plus 66 plus 90 plus 118. So this is going to be 320. The final answer, the sum of the general term Tn with n is equals to 5, from n equals to 5 up to 8. From n equals to 5 up to 8 for 2n squared minus 2n plus 6 is equals to 320. That's the final answer. So, just a comment. We said this is called the sigma notation. And this, when you're given numbers like this, is called the expanded form. So, as we said when we were beginning, you can be given this, and they say put it in sigma notation. So it doesn't matter if they give you this, or some properties of the sequence or number patterns. You should be able to ultimately do this and do this. Okay, so let's summarize this introductory video to series. When you are given a variable in sigma notation, for example, if they say sum of n is equals to 1 up to 3, and they say for n squared, you're going to substitute here in n. First, that is when n equals to 1, so this will be 1 squared, plus when n equals to 2, 2 squared, plus when n equals to 3, 3 squared. This is the first and this is the last. And this will simplify to 14. Another example, when you're given a variable, when n equals to 1 up to n equals to 3, let's say they give you 1 to the power n. Okay, this will be 1 to the power 1. That's the first term. The second one is 1 to the power 2. The third one is 1 to the power 3. We are dealing with this. And this will be 3. So just be careful. This is called an index, so they can even change and give you even a -2, from -2 up to 2. And they'll say a squared. So just start where they've given you and move one step at a time, one integer at a time, up to the last. So this will be a -2 squared for this in the first term, plus -1 squared, plus 0 squared, plus 1 squared, plus 2 squared. 2 is the last term. And when you add this, it's equal to 10. That is when you are given a variable. Be careful. A sum of 3n plus 1. In this case, this 3n is the only one that is being affected by the summation sign. So you do all your calculations here, and when you are done, you add 1. It's different with when you are given a summation of n equals to 1 up to 2, 3n plus 1. then they put a bracket. This means everything is being affected by the summation sign, just like the examples which we're doing. So for this, that's it for now. Then lastly, when you're given a constant, how does the summation sign affect a constant? Let's say they say sum, and say the index is from 1 up to 4. And say your constant is 9. Okay, so there's no variable where these numbers are going. So it means this 9 is going to repeat itself 1, 2, 3, 4. Okay, and the answer is 36. Lastly, let's say another index goes to 1. Let's say up to 6. Or let me just write a 3 here. So let's say you're given 3. This is a constant. There is no variable where you're going to put anything into anything. So this will be 3 should repeat itself 1, 2, 3, 4, 5, 6. 3 times 6, the answer is 18. Okay, so whatever you will be doing, just take note what will be happening. They say the x, so you are going to substitute into x. If they say y, you'll be substituting into y. If they say z, you'll be substituting into z. Everything else will not be affected. This will affect what will be here. Okay, that's it for now in the introductory lesson. We are going to talk about finite and infinite series and how to detect them.